So, you're excited to learn the Rust programming language, and I'm excited that you're excited. But where do we even start? How do we install it? How do we work with it? How do we write our first program, and what is going on inside? Today, we're going to answer all these questions. This series has a free accompanying book in which you can find all the details from this tutorial. Check the description below. My name is Daniel. Welcome to Iris. How you install Rust depends on the operating system that you're using. I'm going to go over Mac and Linux first, as they're both the same and quite simple. Then I'll cover Windows, which is a little bit different. After that, we'll go over setting up your development environment, which is roughly the same for all systems, so use the video chapters to skip to the parts of the video that are going to be appropriate for you. Setting up Rust on Mac and Linux is exactly the same process. Exactly the same except for this one thing. Before we begin on Mac, you'll need to make sure you have Xcode build tools installed. Do that by opening up a terminal window and typing in xcode-select space -- install. This takes a good 20 minutes, so be patient and come back to it when it's done. On Linux, you need to make sure that you've got GCC. Different flavors of Linux use different package managers, but if you're using Linux as your daily driver, I'm hoping you already know how to use yours. To demonstrate on a Raspberry Pi though, I'm going to type in sudo apt install gcc, though you can see this Raspberry Pi already has it installed. Everything else on these two systems is exactly the same, so head over to rustup.rs and pop this into your console. You'll be asked if you want to customize the install. I'm not going to, so I'll choose 1 and press enter. After a minute or two, the Rust installation completes, and it will suggest sourcing the cargo env file. You only need to do this if you want to run Rust tools in the current terminal session, which we do, so we're going to do that. Now we can check that everything is installed correctly by running cargo version, and you should see something that looks like this. That's it, we're ready to go. Head on over to the development environment chapter unless you're particularly curious about the Windows install. Installing Rust on Windows is a little bit more challenging, but you've got this, I believe in you. First, we're going to need Microsoft build tools. To get them, we'll head over to visualstudio.microsoft.com/downloads and download the Community Edition. This installer is your gateway to a lot of stuff, almost none of which we actually need. Click the tab for individual components and search for the following: C++, x64/x86 build tools. Select the latest version. Next, search for Windows SDK and choose the appropriate version for you. I'm running Windows 11, so I'll choose the latest version of that SDK. Then we'll click Install and wait for it to do its thing. This can take a while, so feel free to pause the video here, grab yourself a quick cup of tea. Now that we've got the build tools, we can get the Rust installer, which we get from rustup.rs. Download rustup.init.exe. When we run this, we're given the option to customize the installation. I'm not going to do that, so I'll just choose 1. Once this is complete, we can check that everything is working okay by opening a terminal, either Command or PowerShell, and running cargo version. You should see something like this. Okay, there's one more step that's arguably optional, and we probably won't need it for this series, but as soon as you step outside of this series, you might run into problems without it. You see, Rust is a compiled language that can talk to and use other bits of compiled code. There are different ways to compile code, and although at this point you can compile anything that we're going to build in this series, you won't be able to build everything that you could compile on Windows. To get a bit further, we're going to need GCC. The easiest way I found to install GCC is via msys2. However, this isn't great. If anyone knows of an easier way to get it, please comment below.
Hey, it's Daniel. I've come back from the future to tell you I found an easier way. When I previously tried Windows package managers for this step, I wasn't satisfied with how you install and, more importantly, uninstall those package managers. While researching a database called CodeLLDB, I found another one called Scoop, which is much easier to use. To get it, head over to their website, scoop.sh, and copy the installation steps into PowerShell. Once installed, we just need to type scoop install main/gcc. We can see that it's installed properly straight away by typing gcc --version. And that's it. We can skip a solid 5 minutes of now unnecessary work. Let's move on to development environments.
A software developer's environment is something that's very personal to them. Some people love Vim and NeoVim, others like Nova, and I'm personally a big fan of the IntelliJ ecosystem. If you've already found the tools that work for you and they have good Rust support, there's no wrong answer here. Use whatever makes you happy. If you're new to software engineering though, and you're not looking to fork out potentially hundreds on tooling, I recommend Visual Studio Code. It's free, it's perhaps the most widely used and supported editor today, and can be greatly extended through plugins. It's the editor I'm going to be using throughout this series as I believe it will be the most familiar to people. Let's go to code.visualstudio.com to download it. After installing it, we're going to need some plugins to work with Rust. To get them, we'll start the application, then click the Extensions button in the sidebar. So, what do we need? First, and perhaps most obviously, we need language support. Rust Analyzer will give us syntax highlighting, autocomplete, type hints, show documentation, allow simple editing, and will just generally make our lives a lot easier. Search for Rust Analyzer and then grab it by clicking install. CodeLLDB is the tool that's going to give us software engineering superpowers. Sometimes you can be working on code and it's not doing exactly what you expect. Happens to everyone all of the time, no need to worry. But wouldn't it be great if you could just step over each line of code as it runs and see exactly what's happening underneath? Low-level debugger will let us do that. We'll cover how it works in a bit, but for now, let's just grab it. The Rust ecosystem makes heavy use of the TOML file format. We'll talk a bit more about this later in the series, but now is a good time to pick up this extension. Finally, Rust developers share code through a mechanism called crates. The crates extension will help us keep any crates that we're using up to date. Again, we're not going to dive into this just yet, but we should get it now while we're here. With all of that out of the way, we are finally ready to create our first program, and after all you've achieved already, you're not going to believe how easy the next bit is. The first program most developers write in a new language is called Hello World. All it does is that when you run it, it will in some way output Hello World. So let's do that. Let's open up a terminal and navigate somewhere that we want to work. So for example, on Mac or Linux, I might make a directory in my home folder. On Windows, I might navigate to my documents and make a directory there. Now, remember cargo from ages ago? We're going to use it to create our new application. First, type in cargo new hello-world. This will make a hello-world directory, which we can open in code by typing in code hello-world. As you can see, Cargo has created a few files for us. A gitignore file, which is useful for version control. Now, version control systems are completely out of scope for this tutorial, but I highly recommend learning one that's called Git. This will let you save your work in incremental steps, as well as being an industry standard method of sharing and collaborating. Cargo.toml describes the program as a whole, what dependencies it uses, and any special preparations or settings it needs. We'll come back to this file in the future, but for now we're not going to use it. Finally, we have our source directory, src, in which all of our Rust code will live. The name of the file, main.rs, is used to tell Rust that we're going to make an executable program, one that can be run. Inside, we'll see that we already have some code. Before I go through it all, let's quickly run the program. We can do this from the terminal, which we can open inside of code. Pro tip for Visual Studio Code users. If you want to do something and you aren't sure how to do it, you can hold Control or Command on Mac, Shift and P. This brings up a little search bar you can use to find whatever you need, in this case the terminal. Sometimes you might have to scroll a little bit to find the exact right thing, but recently used things will filter to the top, so we won't need to do this too often. The terminal should open in our project directory, so all we have to do now is type cargo run. You'll see some output that it's compiled, and then we'll get our hello world written to the screen. Now that was really easy, right? We've just made our first Rust program, arguably ourselves, without writing a single line of code manually. You're going to find that the Rust community has spent a lot of time trying to make Rust as easy as possible to learn and use. Looking at our main.rs, let's break it down line by line. First, we have this, fn main, open parentheses, close parentheses, open curling bracket. In Rust, fn is how we describe a function, and a function is basically just a little chunk of code. We'll talk more about functions in a future video. The next bit, main, is the name of the function. We can usually call functions anything we like, but when we create an executable program, we need one that's called main so that we know where the entry point into the program is. The parenthesis after the name of the function is where we normally put parameters. Parameters are how we pass data into a function, but we don't pass data into the main function, so this is empty. The curly bracket that opens on this line has a matching closing bracket at the end of the file, and that denotes where the function ends. Everything inside is part of the function. Inside of the function we have one line, but let's break it into parts. First, println or print line with an exclamation mark might look a bit like another function. However, when you see a label like println followed by an exclamation mark, it's actually something called a macro. Creating macros is a very advanced topic and we won't cover that until near the end of this series. However, they are incredibly powerful and we will be using them a lot. For now, don't worry about it. All you need to know is that they can do a lot more than functions and often don't behave like functions at all. We still have parentheses delimiting the start and end of what we're passing to the macro, but in this case you could use square brackets or curly brackets. For println though, parenthesis is the convention. Inside of the println we have a sequence of characters surrounded by double quotes. This is generally called a string. Rust actually has a lot of different types of string and we'll go into that a bit more in the next video. Feel free to change this message to see what gets printed out. Before we end this video, I believe I promised you all some superpowers. First, let's make a quick change. Let's add our name into a variable. I'll be talking more about variables in the next video, but quickly we can declare a variable with let, give it a name, and put an equal sign after that, and then a value. String values like this need to be delimited with double quotes in Rust. Quite nicely, this now reads, let name equal Daniel.
Another quick note. If your name doesn't use American English characters, this type of string in Rust is UTF-8, so your name should actually be fine. For example, my cat's name is Yuki, and in Japanese it might be written like this.
Anyway, we're going to modify our println now to include the variable. There are a number of ways we can achieve this, but the idiomatic way to do this is to use curly brackets and put the name of the variable inside. Before we run our program again, if you mouse over the line number on line 3, you should see a little red dot appear. Click it. This is what's called a breakpoint. Now we're going to run our program inside of code by pressing F5 and, error message. Don't panic. This is just because we didn't tell code how to run the program. Luckily, it can work it out for us. This varies a little bit on Mac and Windows, but we're just going to tell it that we want to run it with LLDB. Now, we press F5 again and the program compiles and starts running, but look, it stopped at the breakpoint. We can now hover over the variables and see not only what's inside, but how it's stored. Having the ability to do this is incredible when trying to debug things and understand how something works. And that's it for today. It was a longer one, but honestly, just getting started might be the hardest part of this whole series, and you did it. That's awesome. I'm legitimately proud of you. Next time we're going to make a slightly more advanced program by taking a bit of input and doing some comparison. This way we can get an idea for how Rust looks and feels. If that's interesting to you, don't forget to like and subscribe. In the meantime, seriously, well done. Take some time to reflect on your achievement. You are now an official Rustacean, and I will be here next time.